Okay, so very quickly, I know these are jumping around, but my phone's giving me grief. Okay, last thing I wanted you to do here is state the noble gas they're isoelectronic with. So if you look at nitrogen here we added 1, 2, 3 electrons, so it went from 7 to 10. So this is isoelectronic with neon. Okay, sodium had 11 electrons. We took one away and now has 10. So it is also isoelectronic. I'm just going to write iso with neon. Okay. Sulfur had 16. We added 2. So it is now iso with argon. Aluminum had 13. We took away 1, 2, 3. So it is iso with neon. Calcium had 20. We took away 1, 2. So it is iso with argon. And bromine over here, 35. We added one more. So it is iso with krypton. So that's what we mean by being isoelectronic. Okay. The last lesson I want to show you is what we do with the multivalent, the multiple charged ones. So that's the one that I want to look at with you last here. So that's this one. Okay. So in this one here, we have, just fixing this here a little bit. Okay. Energy level diagrams for multivalent elements. So those are elements that have more than one charge. So they have 1, 2, or many oxidation states. They're not always isoelectronic with noble gases because they have d and f orbitals as part of their highest shell, which none of the noble gases do. They all end in p's. So the rules, if you want to form 2 cation charges, and you'll see these when we do them, those will occur with atoms that have a full d orbital in between an s and a p. So if the d is full between an s and a p, you're going to remove the p orbitals first to give you a charge, and then you'll go down and remove the s orbitals separately, not all together like we did with aluminum. Excuse me. That's because it can allow you to form a second charge. To have multiple cation charges, this is where you have a d orbital that's unfilled. So it has less than 10 electrons and it's got single electrons. And what you're going to do is you're going to remove, so it won't have a p, because if these d's aren't filled, you can't go up to the p. You're going to remove your s electrons first because they're in the highest n value. That will give you your charge. And then the nice thing with the d's is because it's such a big